Okay, this is a new stream. I had a difficulty in the previous one, so I'm just hoping that you can make your way here. Okay, sorry about this. I'm just going to post to streams now. I'm going to post to Teams the actual stream. Hopefully it should be okay. Oh, I don't know, we just had a fault there. Hopefully this will work. I've put a link there, okay? Okay, so I'm going to leave there and come back. So hopefully you'll find the stream and you'll be able to come in. Okay, right, here we go. So sorry about all of that. I don't know what happened. I just had a complete failure and then I couldn't connect to the stream. So let's move quickly. We're on lecture 7, as I mentioned already. I see you're back, so thanks a million, Liam. That's good to know you found me. Okay, so let's get on. Okay, so as I said, we're on week 4. We're looking at JavaScript and JSON, and it's going to be really cool. So up until now, we've been looking mostly at clients. Now we want to look at clients and servers and making it all connect and work using JavaScript. So that's the topic is going to start and continue like that for the next while, and certainly the next three weeks, including this week. Okay, so we're going to be looking at JSON in JavaScript applications. Okay, both the client side and the server side, and we're also going to see Node.js. I'm going to say how it will work for all the server side examples, and I'll show you this running today, so that should be nice to see that. We're also going to be looking at how the web works, okay, and how HTTP works, by examining very simple client-server interactions. And I'm going to give you some demos of those today. And we're going to begin by reviewing client-server communications in a web or internet environment. And that means we're going to look at 2 software services, both a client and a server. And I'm going to write a very simple, or build a very simple client, and I'm going to build a very simple server. And these are going to be HTTP servers. So in other words, they deal with web traffic. Okay, so at the moment then basically we're going to use HTTP, which is the Hypertext Transport Protocol. And that's the protocol that's used to allow clients and servers to communicate with each other. So up until now, we've gone to a server. You go to Google, you type in the URL, which is the Uniform Resource Locator, the address, if you like, of some service. You type it into your browser, and off it pops and finds the server, downloads the page and presents the page. Now you know at this stage how those pages work and how they're built, because you looked at CSS, you looked at HTML, and you looked at JavaScript. And those 3 combined together allows us to build all sorts of web pages. Now we're interested in putting those web pages somewhere on the server and then retrieving them and being able to display and act on those. But the very basic step is that communication between the client and the server that says, the client says, well, where do you want me to go? And you give it an address. This is okay. I'm going to go there and find that service. And that all happens nicely with underlying networking. And you'll know all about that from your network courses. And then you give it the file that you're interested in retrieving. So it might be index.html or something like this. And the server says, okay, I'll find that on my disk and I'll deliver it to you. And then it delivers it over the network using this HTTP protocol to encode the content. And then the client's job is to say, okay, now I've got all that, I've built all this stuff, so now I'll do something to display it. Okay, so those are the steps. So some of the underlying content you will have covered, or you will do later in your networking or operating system concepts in another CS modules. And people taking this module have different levels of expertise, but I'm just going to show you the basics and how it will work, you know. So the first thing we need to think about is that we're often talking about web-based client-server communication. We have client-server communication that isn't necessarily web-based, isn't HTTP-based, of course. I mean, if I'm playing World of Warcraft, then I will use UDP rather than TCP, and I'm going to, you know, it's faster to work that way than sending the packet. So there's underlying networking communications going on. A lot of the time, if I'm playing games or something and you want to access the information from that game, they have these APIs that I can actually communicate. Those are called REST APIs, and they're web-based as well. So there's lots and lots of different kinds of things. You may have 2 clients talking to a server. It may look like you're talking to each other. Maybe you are. If you have peer-to-peer communication and so forth. So they're all very nice, you know. So we have these clients like browsers, though. they establish this network connections with a server located at some specific address on the web, an IP address. That's an internet protocol address, using some predefined ports. Okay, so these ports allow us to be able to access resources on the server, if you like, or controlled or managed by that server. So the data are exchanged as text using some specific protocol, and here we're interested in HTTP, Hypertext Transport Protocol, and the server's job was to find the resource quickly and then serve it to the client. That's why it's called a server, and then disconnect so I can serve the next person that comes along. So usually servers are in a state of readiness. That's the whole notion of this. So it's ready. So they're waiting for the next request, servicing it, going back to waiting. And modern web servers are very capable of much more complex cycles than this, but the operation is fundamental. So you sit and wait, you get a request, you service the request, you disconnect and get back and look for the next one. Okay, so that's basically how the servers work at their simplest. Okay, they're very simplest. So you don't need to know about how it all works really at a network level, but you need to know that there's a well-defined language or protocol that's used by the browsers, and browsers are just HTTP clients and servers who can talk HTTP in order to communicate with each other. So it's a protocol. Okay, so in general, you don't see any of this happening. It's all hidden from you. But when you specify a URL, Uniform Resource Locator, your browser performs all of the necessary protocol handling in order to retrieve the document or resource, that's a better term, from the server. And some documents are static, okay, fixed, and some are dynamically generated by the server, or they're embedded in the application at request time. So there's lots of fun things, and it's nice to see you guys. Thanks for coming along. I'm glad you found me, so it's great that you're here. So I've got some nice examples and demos of real-time playing with servers that you can do on your own with your own computer. They'll work under Windows, they'll work under Linux, they'll work under Mac OS, and you can get a real understanding of what's happening at this underlying level before you start writing your own. So we're going to use, first of all, we're going to use Linux. I mean, if you use Windows, you can install Linux tools so you can make things work, or you can download and make these things work yourself. And if you use Mac OS, of course, it's there already. You know, you use Homebrew to install some of the tools that you would have. And of course, with Linux, you can apt-get whatever you need if it's not there already. So here now is our first set of examples, and I like this stuff, you know, and it's really, really nice, and it's, you know, you're really hacking the lower level to see what's happening here. So what we have on the right hand side over here then is an example of a HTTP protocol, a communication between a client and a server. Now we're going to use a client called curl, C-U-R-L, which is a command line piece of software that allows us to be able to download something from somewhere on the web from the command line. And we're going to look at the server. So we're interested in looking here, we're looking at using curl to produce, here's the instruction, if you like, to produce the desired effect, which is to download this file called index.html from this server running on localhost and port 8000. So it's a service that's running on a computer, your local computer. And you know, it's user agent is the name of the client that's making the request. And it's telling it, this accept here is telling the server, I can accept anything you give me. I can handle this, it's fine. Okay. So we're going to see examples using simple Linux command line tools. We're going to look at Apache a little bit later to build our own web servers and use that web server. It'll be nice for our work. But we have a whole bunch of really fun things that we can do with curl and a piece of software called Netcat. And that's a computer networking utility for reading from and writing to a network connections using TCP or UDP. It's a very powerful piece of software, you know, and you can have great fun with this. So really what's happening here is that this is the basic communication that works. So we're telling a server, get me this file using this protocol, HTTP 1.1 or 1.0, you know, you'll see as well, from this server, and using this agent, and we can accept all of these different kinds of documents because we can display or do something with them. So you can see, for example, if I said, this is the URL, localhost 8000, this is the file. So let's do it, okay? It's fun. Let's do this stuff. So I have everything kind of set up. Okay, so here the screen looks a bit busy. Okay, it is a bit busy, but it's just a display for working, and we can make things happen. So I've got some demo files for you. Okay, so the first thing that we would like to be able to do, let's clear the screen here, and everything's a bit transparent at the moment, so we'll just make everything a little bit darker so we can see what's happening here. Okay, so I hope that screen is visible and readable to you guys. So let's go back to our screen. So the first thing we're interested in doing is we want to create a server using Netcat that listens on port 8000. Okay, that's our plan, right? That's the first thing we'd like to do. So let's just copy it. So we can say nc-l 8000. So let's go to our command window. We go nc-l 8000. So now I'm listening. So what's happening here up in the right corner is that I'm listening on this. So I've got a server that's listening with TCP by default. What's happening here? So now I want to access this. Okay, so now I'm going to access this port here. I'm going to say curl. I'm on the right hand side over here now. Okay, I'm here. I'm saying curl localhost because that's where I'm working currently and locally. And I will give me the file index.html. Okay. Maybe I should probably. Okay, so I've hit the request here, okay. And I'm asking, and so you can see that what's happened here is I've got a message from curl to tell the server to give me this file index.html. Now, it doesn't know how to find it. You know, it's looking for it. So we could actually send back some HTML here, okay? If we wanted, we could write some HTML and we could do this. So this panel on the left-hand side is where my server is running. This panel on the right-hand side is where my client is running, okay? And this panel has not been used currently, the bottom one, okay? Thanks, Garrett. Always ask if you're unclear of something. It's a good idea to do this. Okay, so what's happening is that first thing we did was we set up the server. It's running here. Then we have a client which is running here, and we made a request to the server, and the request is actually echoed on the display in this panel here. This is the message that came. Okay, the message that came from the client. So now we want to respond. It's waiting for a response. You see this little dock here is waiting for a response. It's not a very good server because it hasn't serviced yet. So let's see what we want to do and send something back. Well, we could send back some HTML actually. So we could copy some HTML and do that. So here's some HTML. Let's have a look. So here's some HTML. Here. Okay, a web page served by Netcat. And we can send that back. And we'll post it in here. And as we posted our HTML here, it was immediately sent back to the client here. Okay. And we'll control this. So we'll hit return. And you can see it appears here on the right. And we can control. So we finished. And so we've serviced it and connected. And that's a very boring server, okay? But what happened is basically, so this is what's happened. So what happened is that localhost refers to the current machine, okay? So it's a shorthand address, or URL, or network address. 127.0.0.1 is the IP address, but it's the localhost is where it is. Port 8000 is kind of a port number where we're actually accessing it. So you could think of it as a bit like you know, a postal room or an exchange, and then each of the phone numbers are pigeonholes or something that would refer to the actual ports. You do this in network. So this is nice to have this. So we were able to run and access our web service very easily from curl. We could have done the exact same thing by using a web browser as our client. So let's run this again. So I'm going to clear this. Okay, so we're here back on the left-hand panel. I'm going to run the server again. I'm going to do netcat nc-l 8000. And I'm choosing this because they're kind of standard defaults. So it's sitting there. So now I have my server. I have my server up here, and it's sitting and waiting. And this time, I'm going to use a web browser to access. So I'm going to say to the web browser, this time I'm going to say localhost 8000. It's sitting and waiting. You'll notice that nothing has happened. We're actually waiting for the host to respond. Okay, so let's go back here and we'll see this in a second. So I'm going to send in my HTML again that I've written. I'm going to send that back to Google, and hopefully when we go back to the browser, Chrome, it wasn't Chrome, it was Safari, it can't open the page because it timed out. So I needed to be quicker. I was talking and I needed to be quicker. So so I'm going to just try it again. Okay, I'm going to go back and set up again, and I need to be quick. Okay. Okay. Oh, I'm too slow. I can show you a little bit better in a second, because what's happening is, this is the problem. It's not being particularly happy. But what's important, I guess, we see is that we can see that the request was coming from Google here, or from Chrome, and it was slightly different to the one that was Chromium. So slightly different to the one that we were coming from curl. Okay, so don't worry about this. The fact that it didn't respond fast enough is the browser being very careful and saying, I'm not going to hold things up, and the server's not really working, so I'm going to do that. I'm not working as fast as the browser would. So we can look at how we might fix all that. Okay, so we want to have a better kind of service there. Okay, so let's see how we might do this then. Okay, so I'm going to clear this up again, and I'm going to go back to the slides, and we'll have a quick look at how we might make a better server. Okay, so what would be better is that if we were to run the Netcat server continuously, okay, to make it work. Okay, so it's constantly looking and it's responding to the servers. So this is basically a looping server. Okay, so we want to be able to loop over this. So in other words, while we're going to run Netcat again, but we're going to embed it in an operating system shell command. So while true means that forever, loop forever, copy this file to the output, index.htp, and then we'll do this. So let's have a look at this. So let's go back, have a look at HTTP. The bottom screen now. Okay, so let's have a look here. So now let's have a look at the file HTTP. So we look at this. What was it called again? Called index.htp. And we can see this is a very simple file, okay, that contains some simple information that we had typed in previously. And the idea now is to set up our server so that it constantly feeds this to requests quickly and in a way that web browsers will be able to see this. And I see the message of Sinister. I'll come back to you in a second about this. Let's finish this example and then we'll be able to make it work. Okay, so let's go back and copy our example. So now we have this nice command that runs a very simple Netcat server for us. Okay, so let's go back to our client up here and run this. Okay, in the top left. So now our server is sitting there and doing the work, and we should be able to curl again. We should be able to go to, if we go to the window on the right here, and we get our response. So that's exactly what we wanted, our response, and the server responded, and it's waiting for the next request. So we could request again if we come to the window on the right, and we get another request. Now let's go and have a look at doing this from our web browser. Okay, so we can do this from the web browser now, and we'll respond now. And we see we got the response. We got the request from Google, and we got a simple web page response served by Netcat, which is what we expected. And we could do the exact same thing with Safari, and we can get information about all the information about the individual browsers here. So that's quite happy sitting there and running. So we need to kill this. Okay, it'll keep doing this until we kill the process, and we can do this. I gave instructions in the slides. So we can get a process. We can use this command to get the processes, get a list of the processes, look for all the Netcat instructions, and get the process ID, which we can do this. This is basic Linux, okay, basic Unix. We do it here. And we can see the process is running 1567 here. So we can kill this. Should have killed it. Didn't kill it, did it? Sorry, the process is not 1567. The process is 4340. Sorry. Should have killed the process. No. Not in the window. One sec. No, not killing it. Oh, it's not killing for me. It doesn't like this. So where are my processes? Netcat is still running there. 7. Got some problem here. Okay. Some messing. Okay, it's there. Okay, I think I've killed it. Still misbehaving. Okay, I'm not going to worry too much about that. We'll come back to this again a bit. Okay. Of course, computer science, it will always go wrong. Okay, but I guess the main point of the exercise here is that we can run these nice little servers. So what I want to do now is really show you about Node.js. Okay, I'll kill the processes in a bit. I don't know why it's not doing it for me. But so we'll use Node.js, which is this JavaScript service. It's a platform that's built on Chrome's JavaScript runtime environment for an easily building fast, scalable network applications. It provides a runtime environment that executes JavaScript outside of the browser, in other words, at the OS. So Node.js uses this event-driven, non-blocking I/O model. It makes it really lightweight. It's very efficient. It's perfect for data-intensive real-time applications that run across the devices. And it's really, really nice. And it means that we can write server-side code in JavaScript, which means we can do full-stack development, the front end and the back end. So you can already write some JavaScript, then you can start writing Node.js applications. There's no DOM to worry about, but you'll have to understand the event model to make it work. And that's where it all happens. Okay. So what we want to do now is we want to create a minimal web server with Node.js. So that's great fun. Okay, so Netcat was fine. It's very limited in what it can do. We look at a better HTTP server, and this time we're going to do it using server-side JavaScript and Node.js. So here's a very simple web server that's written in JavaScript. Okay, it has a built-in and uses a built-in module called HTTP, and it basically creates a server and runs this server. And this one is going to listen on port 9000. So let's see how that works. Okay, so let's go back and run this server on 9000. So I think I have this working already. Fingers crossed. Okay, so here. We'll see how this goes. So these are all the files that I have. I give these for you, of course, as well. So I have http.js. Okay, so this is the file. So let's have a look at this. Yep, that's the basic server. Okay, so I know this is the one. So we're going to run this, and we run this by issuing the command node http.js. So now we have a server running on port 9000, written in Node, and it should behave nicely. And we can look at it with our browser. We can look at here's our web server. Okay. Okay, and we have a web server that's served by Node.js. Okay, so I can just make sure it works everywhere. And I can have a look at it in Safari as well. And I'm going to look at this again. Okay, so and again, I have it working fine. So this works everywhere. It's really nice and it works very well for us. Now, we're issuing the command to look at index.html. But actually, if we go back to the code, we'll see that nowhere am I specifying an actual file to load. It just writes the same response regardless of the file that's called. Okay, so so we're not going to that's not particularly exciting. So we might like to change the server so that it would give us an actual file. Okay, so we can make it do that as well, and we'll see how to do that in a little. So this is a server side. So it was very easy to write a full-blown HTTP server written in JavaScript really, really nicely. Okay, using Node.js. So really what's happening here is that all it does is sends a message, a web page served by Node.js, okay? So the server is launched on port 9000 on the last line of the code in this.listen code here, okay? And then we use this require statement at the beginning to make a call to Node.js library called HTTP. And that provides all the functionality to build this web server for us, okay? So we don't have to do that. We saw it in the demo. And you can install your own libraries using the Node package manager. Node package manager is npm. And HTTP and URL, as you'll see later, they both come with Node.js as a standard, so you don't have to actually do that. For Node.js, I installed mine using macOS and Catalina using Homebrew. And just to get back to the question I was asked earlier, is there any difference in these commands across the operating systems? No, they will work fine across Windows and Linux and macOS. As I said, you can install your Node and your Netcat, by building them if you want. But I would use, if you're on macOS, I recommend Homebrew, and that will work there. And again, you can download these for Windows as well. Okay, so it worked quite well. As I said, the instructions are here. You'll be able to copy and make these work, and you can make it work as well for you. So I'm going to just go back, and I'm going to kill this because I don't want these things running around. So I'm going to control. So I've just got rid of that server now. It's not running. If I try to contact the server again, okay, can't connect server because the server doesn't exist. So the server's offline currently. Okay. So that's a little bit about those servers. And again, you can use Node.js. It's much better. So I've given instructions in here on how all of this piece of code is written, or explained how it's all written, and you can have a look at that. And so I'm not going to go into that now because we're a bit under pressure time-wise and so forth, but you can have a look yourself. Okay, so we can have a better JavaScript server. So what we want to be able to do is we want to be able to specify the actual file or the URL. Okay, so previously all we did was we could specify the URL, but it was ignored. Okay, but now we want to be able to do that. So we can actually give it the name of a page, and we could actually pull in that page if we wanted. And we can get the URL from the request object. We'll come back to this a little bit later, and when we look at this in more detail. But this is just to give you a sense of how it will work. So we're going to, the takeaway here on this slide is that we can use the URL module in order to be able to pull the URL from the request and then make it work. So also, if we knew how to do file handling with Node.js, we could search for the file, then open it, read the contents, and send that back to the requester. So Node.js provides a file system library which allows us to be able to do this. So we can actually use server-side JavaScript to do file handling. So we could read the file, and then when the file is full, and we've opened the file, got the data from the file, we can send it back to the client. That makes the request, and that's the purpose of this. Okay, so Chris, to answer your question, yeah, Node.js allows us to be able to build apps, lightweight apps, multi-threaded apps on the server side, and it's really useful. Tig was saying that the shell is a bigger factor than the OS. Windows has some annoying catches. Yeah, the file system. I mean, I've been correcting assignments and so forth, and I look at this, and there's backwards and forward slashes and so forth. But you can get a shell to run in Windows that allows you to be able to have Linux type commands, and it's what I tend to use myself. Okay, and then I can use the same commands on macOS and Linux and Windows, and it all seems to be fine for me. Okay, so here's a better web server, and I'm giving you the code so you can play with this yourself. And basically what happens here is this allows us to be able to use HTTP, which is the protocol to do and build some web servers. URL allows us to be able to pull out the files we want, file name, and then require file system allows us to be able to open the files. So this is a very straightforward piece of software that handles text and HTML files and allows us to be able to process text and HTML. So the content types it deals with are text files. It doesn't work with images, just with text files. Okay, so it's a very straightforward one, and we're telling the client when they make the request, yes, we're sending you back a file of this type, file and text. So it all works quite nicely, and we'll come back to this again in a little while. I just want to show you whole programs that work. So now I have a file here, so we can look at some files. So I have this, it's called, it's on my server. I can run this for you, and we can see how it goes. let's get back to here. Let's look at some of the files that we have here. Okay. And you'll see that I have something called HTTP page.js, and this is the one that we will execute to make it work. Okay, so let's have a look here. So we'll run this. So now we're listening for files. Okay, I'm going to deal with files. So I was interested in a file maybe called readfile.html. So, or Star Trek.html. Let's see what they are. Let's see what they are first. Click here, see what these files are. So let's clear. Where am I? Okay, so let's have a look at that. Okay, so this is a simple file that was read by Node. Okay, so we can try to read this file then. Okay, so it's called readfile. So let's go to our browser. So the server is running here. Go back to our browser, and we're going to look at, we'll see here. Okay, so this is the page was not found because we're looking for a file called index.html. Okay, and we don't have that file created deliberately, so it tells us that the file was not found. But if we ask it to find the file readfile.html, it should do that for us. And here's the file that it read. So this is a more expanded web server because it allows us to be able to look for the files, extract a request for the file that we wanted from the URL, then use that to search for the file and make it work. Okay, so it's really nice too, and it works really, really well for us. Okay, so were there any other files there that worked? There was one called Star Trek.html. Let's see what that is actually. See what Star Trek.html is. Okay. Trek. HTML. Okay, okay, so it was okay. So this is a piece of Star Trek. Okay, so this is dealing with JSON from a later example. So basically, I was able to create a JSON object from string. I was able to build this string. Commander Deanna Troy was counselor in the USS Enterprise NTC 1701E. So we can and that came from a file. It came from this file here, and it worked really nicely for us. So that worked fine. What happens if we want to be able to deal with images? So I have an image here. If I see that there's a file called po.jpg here, okay, so po.jpg is an image. So let's see if we can read this. Okay, let's see if we can read this file. It's an image. It's not text file. So it will try to interpret it as text because we told it to do that. And we get this. We get all this nice, because what's happening is that we're taking an image, which is a binary file, and we're sending it as text back to the server. So the client hopes to interpret this for us as text, and it's not text. So we need to go and make a change to our server so that we can deal with images. So let's quickly do that. And this is why playing is such good fun, okay? And very simple files, you can do all sorts of fun stuff, but you really will get a good understanding of how it all works. So let's make a change to the file HTTP. So VI is a visual editor. I use this when I'm using, people use Emacs. I like VI. So we'll go here. And so this is the section that we need to change. We need to tell it, instead of sending text and HTML back, we want to send back images. So let's do that. So we'll look at images then, get rid of this stuff. Okay, saved it. So now we're going to run the server again. And this time it's a server, a web-based server that allows us to deliver images. So we can go back to our web browser and reload, looking for this image po.jpg, and see what happens. And we got our poll, okay? And post friends, of course, as well. So you can do all sorts of everything that happens in terms of the communication between the clients and servers controlled, and you manage it. And so your web servers are really powerful, and to be able to handle text and images and all sorts of other files, or you want to be able to just do, you know, all sorts of fun stuff, really, whatever you want. You could have a piece of hardware. You could have your web server with Node.js running on a Raspberry Pi. It could be having sensors, and then you could have your Node.js program talking to your sensors, giving you the temperature outside. It could be looking at the camera. It could be doing any of these things. You could have a battery-powered Raspberry Pi, you know, attached to resistances on your arms and running down your clothes, and you could move about and wave, and it could be all captured by the sensors. And then, you know, you could have some dancing avatar based on your actual real movements and send all of that over a web page. There's so many fun things you can do, not too complex, and they're nice projects. And all you need is to have a basic understanding of how it all works, and then simple programs, use libraries, and you can do really, really powerful things. Okay, so that's a little bit on servers, and we'll come back to this a little bit later in the module, okay, as well. I wanted to show you the power of some of the server-side JavaScript. So really what happened here is that if the file exists, we return it. If it doesn't, we just say the file doesn't exist. And then there could be an error and handle it gracefully rather than failing and having the server shut down. But it's very much the same as JavaScript on the client side is very much the same as JavaScript on the server side, but instead of manipulating the DOM, we're working with the file system, the network system, all that kind of stuff. So it's really good. We don't normally have to write our own servers, by the way, folks. You know, this level of detail. As I said, I want to show you the power of full stack development. We use Apache as a server generally, except when we don't want to, of course, you know, and we might have very specialized services that are tied to specific applications, and that's what we're going to do in the next half of CS230. Okay, so let's talk a little bit now, and I'm running a little bit faster than I would like to do, but we had a problem with the stream early on, but here we go. So let's have a look at JSON. So sorry, let me stop for a second. Is there anything you'd like me to talk about? Any questions you might have about that before I move on to JSON, the web server stuff? I'm glad you find it interesting. It is fun stuff, and you can do things. Java is not Apache, is not Java-based server. It's written in C. It's a wonderful piece of software. The source code is full available. You can write modules, your own extensions, and so forth. There is a server from the Apache Foundation that's written in Java. It's called Tomcat, and that allows you to be able to do and deploy Java app servlets and JSP, which is Java Server Pages. It's been around a long time. It's a very mature technology now. Good stuff. I mean, I like it. It's fine. I won't be teaching it this year. And yes, Evan, we will be. Sorry, Tyg, I hope that answers that question. And Evan, yes, we will be using the Express a little bit later. We'll be looking at Mean, and we're looking at the MongoDB and Express, and Apache, and Node.js as a combination. Okay, so that's fine. Yeah, the Apache web server came first, and then the Apache Foundation, and they do all sorts of fun stuff now as well. Some really brilliant tools there as well for doing software development. Okay, so let's talk about JSON then. So JSON is this, it's called JavaScript object notation, and it's a way to store information in an organized and easy to access manner. It offers human readable collections of data that can be accessed logically, and you can find all about JSON here at json.org. Okay, so it's always a good idea to see what's happening. This is a great place to go. So when you're exchanging data between a browser and a server, we've already seen that the data is exchanged in text format. Okay, remember, HTML is text, JSON is text, and we can convert any JSON JavaScript object into JSON and send JSON to the server. So we can also convert any JSON received from the server into JSON objects. So we might have something that we've pulled from a database like MongoDB, for example, in the server side, and we can, or from a relational database. You can convert that into JSON, send it across over the internet and by an HTTP to your client on request, of course, and then you can convert it into something on the client side and manipulate those data very easily. And it's the power of JSON. It's a really, really good communications encoding. So we can work with data as JavaScript objects, no complicated parsing and translation. So very easy to do, very easy to parse, you know. And JavaScript usually consists of a collection of structures. There are two kinds. You have a collection of name value pairs, and this is realized as an object, a record, a struct, a dictionary, a hash table, a keyed list, associated array. And depending on your programming experience, you will know what all of those mean and the languages that it refers to. It can be also an ordered list of values, and that's realized as an array, a vector, a list, or a sequence. And again, depending on your programming experience, you will know some or all of these. But don't worry about the different kinds of definitions initially. You'll come to understand them when we work through these. So here's an example of a reasonably complex JSON data structure. Notice the opening braces. We have name value pairs, name value, name value. We have embedded, so we have a name, and we have actually referencing to another JSON object or JSON here, nested JSON, and we can have all this kind of stuff. So it's a bit like, you know, a structured, very structured data, and that's the whole point of it. It really is just a string. It's not a JavaScript object definition. It's just a string. There's nothing to tell us it's an object, even though it looks like an object, like we've seen already. If you look at JavaScript, var z is assigned the value of x colon y. That is not JSON. That's an actual object. Okay, so there's this equivalence between the objects and the strings, the JSON string. So the JSON representation of this string. So this is an object of type string. And then we can actually parse that string into an actual object using JSON. So there's ways to do all that stuff, okay? And we can see, and you can practice a little bit of that later. So for example, I've got, here's a data model. So I'm trying to represent, I build this database, if you like, of people who are in Star Trek. You know, if you're into that kind of thing, I am some days. So you could have something like this, you know, where we have Deanna, Troy, Commander, like we can try to find a model that represents the various crew, on the starship. So you have Deanna, first name, last name, Troy, your rank and position. But you know, she was also had, so people may have different positions over time with rank and so forth. So this is it's not a good model, okay? Because if you were really interested in Star Trek, you would say this is not a good data model because it doesn't work for everybody. Because data doesn't have a surname. And Worf, for example, I'm sorry if this bores you, okay? Worf has a human surname, but he chooses not to use it. His son, Alexander Poroshenko, does, and Worf could use his Klingon designation as son of Mo, because he's from the House of Martok, but he could be also referred to as Lieutenant Martok. But there's lots and lots of things that we might have to do with modeling. And I guess this is not about Star Trek. This is about trying to understand data models and trying to represent those data models inside in your program. You know, you have I've seen the Voyager fan stuff. Yeah, I always like Janeway myself and some of those stories. But I really liked the most recent Picard one. I thought that was a really good series. But anyway, don't get too distracted by Star Trek talk. But the point is that it's about data modeling. It's complex. JSON won't solve it for you, but it will help you describe your data model when you have it solved. So this work of trying to understand the world and how it might be organized, you can code that in JSON once it's done, okay? Up until now, a lot of your data modeling has been with variables or objects or classes or relational tables, but you can do a lot of this work within your actual JSON too, okay? So we could have, for example, this model here, we could have taken out Starship and reorganized the crews for individual starships, but the data model depends on what you want to do with it. What's important, I guess, is that we can use this dot notation to navigate through the structure and the bracket notation. So I could say something like here, give me crew0.rank, and I could find that would give me commander, okay? And you could figure out that for yourself as a little exercise, okay? So we can actually convert between JSON and JavaScript objects, and you can see that the program that I ran earlier, whereas I had this file here where I had a piece of text, which was a string, and then I converted that string to an object, a JSON object. It was a JSON string, if you like, converted to a JSON object, and then I was able to extract all the various object elements from there. And that's the file that was transferred with our Node.js server over to our web browser, and we got that information about the anetroid printed to the display. So that's the file that I used. Okay, remember, it's all client-side JavaScript, JSON, but we have all these JSON, powerful JSON functions on the server side also as well. Okay, here's how we might use JSON in an application on the server side. So we can create this variable and parse it on the server side, and this will work, and we can just print it to the display as well. So the same code, the same kind of work, JSON processing on the client side and the server side is very powerful. We're only using one record here in this example here, but we could actually have all the membership data and do some fun things with it. So basically, I'm just rebuilding a string from the converted object and then using it as a reference to the property. So that line there tells you how this works. Okay. I'm going to be sending you lots and lots of demos as we work along over the time, and you'll see some in the file handling and JSON and manipulating JSON files in the lessons later this week. So, look, there are lots of JSON resources available online. JSON lint, JSON editor, JSON formatter, all sorts of fun things. I probably should have sent a little quiz to you earlier to see if you were really keeping an eye on what was happening. So maybe you might want to have a look at this quiz. So let me see if I can get this working for you. I'll open the quiz, and I'm interested in which of the content types will work or changing a JPEG to a JPEG image, okay? You know, this is, I'm going to open the shortcut, and I'm going to open for voting. So the content type is a content image JPG, image slash JPEG, text slash HTML, or text slash image. So what kind of content type do we use if we want to send an image to a web browser using our server? Anybody remember what we typed? You know, there's 100+ of you there. I'm only getting a few replies, so I'm sure the rest of you could try this as well. Okay, so good work, everybody. Really good work. We have somebody, most of the class will tell us that I had used image slash JPEG, which is correct. And those of you who said image slash JPG are also correct. That will work too. Okay, so well done. And this text slash image, you would think, can I send text images? That's a good way of thinking about how might we want to send something where we want to send different types of images and different types of texts. And that requires a lot more complex thinking. So yeah, it is possible to do both text and images. And yeah, but it's not this one, unfortunately. So well done on most of the class on getting this right. So you're all very, very attentive and very knowledgeable. So well done. Let's go back then to our slide and have a quick look at the coding computer again. And so what I want to do is just quickly show you before we finish up that client side and server side JavaScript running. So we had seen earlier how we were able to serve our Star Trek page, which was processing processing our JSON on the client side. Okay, so remember we looked at not Edgar Allan Poe, this one here. Okay, so we were able to look at this, and we sent this file from the client, on the client side file from our server. We can have a quick look at the source here, and we can see that here we were looking at the source. We were looking at all our JSON was embedded in a scripts tag on the client side, and it was processed and executed, and we got this message here. So now we could write a server-side version of that program This is the server-side version of that program, which is running, we'll run Node.js to do this, and we're writing to the display here, the console.log. Okay, so we're going to do this, and we're going to, and instead of catting it just to view it, we're going to run it using Node.js. And we have this, which is our server-side program running and producing the exact same piece of information. So we're able to do powerful things. We're able to take that JSON or JavaScript program that we know on the client side and also use much of it in the server side where it doesn't involve any manipulation or playing with the DOM. So that's really useful. But as I said, lots of JSON resources. You can work and play with these yourselves. And you'll get better with time and practice. And so look at the code and look at the examples and see how they might be useful in your programs and your assignments. So I suppose the concluding remarks then is that JSON is a standard text-based format for representing structured data based on JavaScript object syntax. It's used for transmitting data in web applications. Okay, in other words, sending data from the client to the server and back and forth again. Okay, and even though it resembles closely JavaScript object literal syntax, it can be used independently from JavaScript. And many programming environments, they feature the ability to read and parse and generate JSON. You'll see it used in everywhere. So you'll see it used in Java. You'll see it used in Python. You'll see it used in Ruby, everywhere you want to be. I mean, I use it in C# as well, okay? But remember that JSON exists always as a string. And it's very useful when you want to transmit data across a network. And it needs to be converted to a native JavaScript object when you want to manipulate and access those data. And that's a straightforward activity. Every language you will work with will give you some method of creating an object from the string and then creating a string from the object. Okay? Python, all of these languages will do that. It's really, really useful. I see a question popping up there. Is that panel on the right just the terminal? Yeah, it's just a terminal, yeah. It's not the Mac terminal. It's probably something else I use instead of Mac's default terminal because I can control things like opacity and all that kind of stuff there. It is iTerm. Okay, so it's free. I've been using it forever and it's a really useful one. Okay, it's nice. I mean, it's got lots of windows. I can have lots of overlapping windows here. Because I can let me just change the opacity. So I can change the opacity on all of my windows. I mean, you can do that with lots of these things as well, but it means I can flick back and forth between all these. It's useful, okay? Sorry, how you say that you've seen JSON referred to as an example of the universal design pattern. How many times something like it's been invented and implemented in different languages? It's very true. Very true. I think, it'll be a while before we invent something as useful again, to be honest. And I tend to use this a lot when I'm working with projects, especially group-based projects where I have students working in the client side and students working on the server side. We normally describe the API and the communication between all of these first, and then we encode that in JSON. So we can actually have that as our hook so that everybody will work with something concrete, and then the clients, so we can build a whole bunch of JSON manually as data examples or exemplars and have those for testing purposes. So then the server people cannot use those. They know they've got to read those and test, and then the clients people can need to generate those and test. And so both teams can work independently of each other, and it's a nice communication. And we have this kind of thing and done this kind of thing over and over in the past, as you say. I'm 55. I've been doing this kind of stuff forever, but I guess I've been using JSON for longer than all of the other things that I would have used. So yeah, it's definitely useful, definitely powerful. And I'm delighted to have it. Guys, I've gone a little bit over. I'm really sorry about that, but we had a late start and it was worthwhile getting to the end, I hope. I hope you enjoyed the demos. They're a little bit to show you how they will work and the things that you can do and the power that you have. It's about play. I said before, don't worry about making mistakes. If you're not making mistakes, you're probably not learning, and play is the best way to do it. Take my programs, play with them and make changes and figure out what works, doesn't work, and you'll be proficient in no time at all. You're a good class, you're good hard workers. I'm impressed with what I'm seeing. It should be enjoyable too, okay? And have fun. Thank you very much for coming. I see you next week, and good luck with the assignment. Thank you.